This problem is from section 9.3 of the hypothesis testing chapter. It's a one-sample t-test, and it's also a one-tail test. We'll show you that. It doesn't have to be one-tailed, but if it says greater than or less than in the question, that's how we decide it's a one-tail test. If it just says, is there a difference, it would be a two-tail test. So this is problem 946 on page 307. The Los Angeles County Metropolitan Transportation Authority has set a bus mechanical reliability goal of 3,900 bus miles. Bus mechanical reliability is measured specifically as the number of bus miles between mechanical road calls. Suppose a sample of 100 buses resulted in a sample mean of 3,975 bus miles and a sample standard deviation of 275 bus miles. Here's the question. Is there evidence the population mean bus miles is greater than 3,900 bus miles? Use alpha, a level of significance of 0.05. So it says, again, greater than 3,900, so that tells me it's going to be an upper tail test, okay? And alpha has to be 0.05 because that's what it told me. Now, the other thing to notice right here is we took a sample of 100, and here's our sample mean, that's x bar, and sample standard deviation, which is S. Is 275 bus miles. We want to determine the p-value and interpret its meaning also at the end. That's kind of extra credit at this point, but we want to practice it so that you'll be prepared for the second exam when you'll need to know about p-values. So this is the information we're given. X bar is 3975, S is 275, and degrees of freedom equal n minus 1. That'd be 100 buses minus 1 is 99. That's the information we're given in the problem. State the null and alternative is our first step. So because it asked me, and let's go back there and look at it again, it asked me whether there was evidence the mean bus miles is greater than 3,900. So that means it's a greater than sign is what I want to use in the alternative. So that's what I'm doing here. Mu is greater than 3,900. The average number of miles between bus road service calls is greater than 3,900. The null says mu is less than or equal to 3,900. The average number of miles between bus road service calls is less than or equal to 3,900. Okay, one tail upper test again because that's what the question asked for. If it just said, is there a difference? Is it different than 3,900? It would be a two-tail test. Step 2, n equals 100 buses and alpha equals 0.05. That was given. Step 3, because we're testing whether the mean is greater than a certain value, it's going to be an upper tail t-test for the mean. We're interested in the mean. It's an upper tail test because it says greater than, and we don't have the population standard deviation. All we have is the sample standard deviation. We are assuming a normally distributed population and a random sample. The population has to be normally distributed because the sample may or may not be. In this case, however, if we look back, we do have a sample size of 100, so it's probably pretty close to normally distributed anyway. Here's our Excel test results. If we do a t-test for the mean for one population, this is what the result looks like. So we have null hypothesis mu we think is 3,900. Our level of significance is 0.05. Sample size is 100. Sample mean is 3,975, and sample standard deviation is 275. So if we use this t-test for the hypothesis of the mean, it will provide us with the numbers that we need at the bottom here, and also tells us, if you look all the way at the bottom, this is with pH-dat now, if we use that, if you want to use that, reject the null is what it says. Goes back to our steps. We did up to step 3. Now we're going to do step 4. Determine the critical value. So the critical value is based on n minus 1, 100 minus 1, 99 degrees of freedom. Alpha is 0.05. And my t value, according to my printout here, is 1.6604, upper tail critical value. You can also see that in the table down here. 99 degrees of freedom, upper tail area 0.05, one tail test, so it's just 1.6604. So that's my value for step 4. It says if I get anything greater than that, I'm going to reject the null. If I get anything less than that, I will fail to reject the null. Step 5, I've got to calculate t. So I can plug into my formula right here and solve, and I get t equals 2.73, or I can look at my Excel output again, pH-dat, 2.7273, and that value is greater than 1.6604, so that's going to cause me in step 5 then to reject the null. Because 2.723 is greater than 1.6604, we will reject the null. We're 95% confident that there is evidence to conclude the population mean bus miles is greater than 3,900. And that should say mu is greater than 3,900. Then it asked me for the p-value in part B, and what does that mean? Well, the p-value, again, the best way to find that is if I'm doing a t problem, I can only estimate that based on a table. So if I use phstat, it'll tell me exactly what the number is, 0.0038. So if that's my p-value, then it is less than 0.05. It's going to cause me to reject the null, which is what I decided. And actually, if I take 1 minus p, that's going to give me my confidence level, which is 99.62% confidence in our decision to reject the null. So, because p is less than the level of significance, or alpha, we'll reject the null and state that the average run of the bus is greater than 3,900 miles before it needs to be repaired on the road.